Next problem. Random sample drawn from 2 countries gave the following data relating to the heights of adult males. So they have given data. First question is the difference between the mean significant. Second question is the difference between standard deviation significant. So they asked 2 questions. One is difference between mean idea, right? You have to use difference between mean test. Second one, difference between standard deviation test. 2 tests, right? Given sample size n1 equal to 1000, n2 is equal to 1200. Sample means everything is in the given table, right? x1 bar 67.42, x2 bar 67.25. Standard deviation s1 is equal to 2.58, s2 is equal to 2.50. So for means, first question, defining hypothesis, there is no significant difference between mean. Null hypothesis. So H1, just opposite to that, there is a difference between the means, right? We are using two-tail, right? So the level of significance they have not given, we are taking 5%. Test statistics z is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2. Substituting the values, 67.42 minus 67.25 divided by root of 2.58 the whole square by 1000 plus 2.50 whole square by 1200. So you will get 1.5611. So calculated value of z is 1.5611. Tabulated value at 5% level 1.96. So conclusion, comparing calculated and tabulated. Calculated is less than tabulated, therefore H0 is accepted. There is no significant difference between means. Next, standard deviation, defining hypothesis. So H0, there is no significant difference between standard deviation. H1, there is a significant difference, right? So two-tail test, again the level of significance we are taking 5%. Test statistics, z is equal to s1 minus s2 by root of s1 square by 2n1 plus s2 square by 2n2. Substituting the values, 2.58 minus 2.5 divided by root of 2.58 square by 2 into 1000 plus 2.50 the square divided by 2 into 1200. You will get 0.9852. So calculated value is 0.9852. Tabulated value is 1.96. So conclusion, calculated value is less than the tabulated value. Therefore, H0 is accepted, right? So we missed the conclusion. Just write the conclusion, right? That means there is a significant difference. There is no significant difference between standard deviation. That is the conclusion. Next problem, problem 4. The mean yield of 2 sets of plots and their variability are as given below. Examine whether the difference in the mean yields of 2 sets of plot is significant and whether the difference in the variability in the yields is significant, right? So two type of field, right? Different type of field, and the yields, different type of yields from the 2 separate plots, right? They have given the data, right? We'll see. Given sample n1 is equal to 40, n2 is equal to 60. Sample means x1 bar is equal to 1258, x2 bar is equal to 1243. Sample standard deviation s1 is equal to 34 and s2 is equal to 28. So mean, defining hypothesis, there is no significant difference between mean, right? Alternate hypothesis H1, there is a significant difference, right? Two-tail test, let the level of significance be 5%. So test statistics is equal to x1 bar minus x2 bar by root of s1 square by n1 plus s2 square by n2, that is equal to 1258 minus 1243 divided by root of 34 square by 40 plus 28 square by 60. So you will get 2.3155. So calculated value 2.3155, tabulated value 1.96. So conclusion, calculated value is greater than the tabulated value. Therefore, H0 is rejected. H1 is accepted. So there is a significant difference, right? Next, standard deviation. So defining hypothesis, there is no significant difference between standard deviation, that is null hypothesis, right? And alternate hypothesis, there is a significant difference between standard deviation, two-tail, right? Level of significance 5%. Test statistics formula S1 minus S2 by root of S1 square by 2n1 plus S2 square by 2n2. So that is equal to 34 minus 28 divided by root of 34 square divided by 2.2 into 40 plus 28 square divided by 2 into 60. So you will get 1.31. So calculated value of Z is 1.31. Tabulated value is 1.96. So conclusion 1.31, that is calculated value, is less than the tabulated value 1.96. Therefore H0 is accepted. So that means there is no significant difference between the standard deviation. Thanks.